We're going to go ahead and get started. I want to make sure I have enough time to do the demo tutorial as well as plenty of Q&A. If you have any questions, please put them in the chat and I will address them when I get a chance. So my name is Dylan Agnes. I'm from the Integrated Design Lab. We're part of the University of Idaho. We're a research and consulting firm, nonprofit. We currently have 7 members in our lab. We've grown from 4 over the past couple of years, so we hope to keep doing that. This lecture is sponsored by Idaho Power. Some of the other services offered by Idaho Power, we have our foundational services. All our operations right now are virtual, non-contact, so Zoom webinar. So if you need to get a hold of us for technical design assistance, you can send us an email. If you call our office, you will get a voicemail, but we will receive that voicemail and give you a call back. BSUG, currently I'm presenting the state of Autodesk software using Insight. Next month we have Ryan Swartz from Cushing Carroll utilizing Grasshopper and Ladybug for early design. September is still up in the air. We would like to have the topic be about power over Ethernet, the Internet of Things, and microgrid potential. We're still trying to lock down a speaker, so stay tuned for that. In October, we have Tim Johnson, also from Cushing Carroll, on the performance modeling for standards and code compliance. Then November, we have our own Dr. Damon Woods for about speaking on high performance classrooms. And then December 9th, we would still like to hold our stakeholders meeting, which is just a round table discussion about the topics of BSUG that year and potential topics for next year on what you guys would like us to see present or speakers you would like to see present at BSUG. Right now, that's still scheduled to be a Zoom webinar. And then we have the tool library. I'm going to go a little off script here for a second. Bear with me. So currently right now we have a contactless pickup drop-off system. We're located at the Water Center. So basically you still fill out a proposal as you normally would. And then once you've submitted that proposal / request to borrow tools, I will email you to set up an appointment for picking up tools. So it's just in the garage, temporary parking. I come out and I load the tools into your car, drop into the trunk preferably, and then same thing for pickup. You just show up and I pick up the tools. All tools are sanitized and disinfected before pickup and upon drop off. So something to note is you will not be able to use the library if you do not have an appointment. Okay, that's just the new policy we've had to implement. I'm sorry. So yeah, the tool library is still operational. Please be sure to check out other incentive programs from Idaho Power. You can visit idahopower.com/business. And then let's get started into the lecture. So we're going to be talking about Revit using Insight. We're going to go over a model introduction on just the formats, CAD, 3D modeling to BIM, what Insight's goals are, what it's trying to achieve, what part of the market or void it's trying to fill, where are we going. My opinion, Revit is leading to parametric analysis and modeling with the latest Insight and cloud features they've over the past couple versions. I'll briefly talk about the simulation methodology used here at the lab and kind of how it compares. We use EnergyPlus Open Studio, and we'll kind of do some comparison and contrast against the Revit with Insight. And lastly, I'll go over Revit with Insight, the settings, the differences, how to get started, generate a simulation, what the settings do, which ones you want to be using at which stages in the design process, and then hopefully we'll have enough time that I can actually show you guys some models that I've been working on and give you a live tour, so to speak. So modeling introduction. Modeling is an aspect of the design process that has undergone rapid change and adoption by multiple disciplines to help shape the built environment. The most notable one that I've found through research is the construction industry. They have been very receptive to BIM technology and integration into their discipline. So while we do like to believe in, BIM is advertised as, trying to achieve the integrated design process, my opinion, the reason why it's been, more readily and accepted and evolved into the process of various disciplines and how they design is because of just reducing time and money. It's the economics of it. It's really efficient, saves you a lot of money, lets you plan, lets you do simulations. Construction industry probably uses this most for simulating cost and time frame for building and construction. So on the left, you see we have the classic CAD, computer-aided design. What that kind of brings to the table is layers, starting a database, as well as increasing the workflow efficiency for design. Then we get, 3D computer modeling, which is very similar to CAD. It just, however, fully incorporates the Z-axis, and we start to expand that database to include other things other than just layers, so that we can achieve rendering, so we can actually see, what the building is going to look like. And then we have BIM, probably the biggest explosion, whereas that, it's a complete project database, and not only that, you can have multiple project databases in the same project, and then, that really helps integrate the disciplines because you're sharing data, it's overlapping. And probably the biggest is that you can run simulations and analysis more effectively because of that sharing of data, because of that integrated discipline. So the other reason is, we've seen a decrease in the hardware costs and increase of computer speed in storage since the 70s. BIM, I believe, was first mentioned in 1992. So, that kind of coincides with the evolution of processing power and hardware and how effective it's being. The biggest takeaways from it is we can do complicated building modeling through digital construction. And furthermore, that we can get accurate information for project construction, fabrication, and analysis. Yes. So the first paper describing BIM was published in 1992. It was titled Modeling Multiple Views on Buildings. However, it isn't until about 2006 that we see the literature started to be more focused and assertive in relation to BIM research and development. As in, what else can we do with this other than just storing information in a unique way? And so you can the graph on the left kind of shows you published articles related to the BIM topic, and you really see a huge interest out of 2013 to 2015. And so here's kind of a summary of those categories that were published. The ones we're probably most concerned about would be the BIM adoption and standardization, BIM and spatial information, collaborative environments and interoperability, construction management, and sustainable construction. That's kind of a bit of life cycle costs as well as a bit of energy use. It's kind of a broad term. So as I mentioned earlier, one of the biggest selling points of BIM is the integration of disciplines to achieve the integrated design process. And so we can see that the collaborative environments in interoperability has 78 papers published the most. However, if we look further into that, it's only 19.7% overall. However, the volume of which they were published was when we saw that huge increase of interest in researching BIM and what the capacities of it could be. So 2013, 2014, 2015, we see a huge increase in how do we actually push this envelope and get people to fully work together. So it's around the topic of information and knowledge exchange between BIM tools, highlighting the potential of BIM as an information repository. So reasons why BIM has had such a problem integrating into the AEC industry. It's various disciplines kind of pulling them together. Can have complicated manual data for input, just too many variables or factors that have been known ahead of time that may not be known when you're in a certain phase of the design process. Another one is the formatting of data isn't compatible. So often when we're defining a building's characteristics, such as HVAC, lighting, or scheduling, we use separate programs for it. And sometimes those programs don't like to speak to each other. It's just not the intended use when it was designed. So it has to be updated to do that, or a new methodology, a new format of data storage and sharing has to be created. The biggest one, in my opinion, is that the building is just defined in separate stages of the design process. The most crucial phases of the design process, in my opinion, are the pre-design, the schematic design, and the design development. So here's kind of a look at that design process. So usually on the effectiveness of making certain decisions for sustainability or integrating building systems to work cohesively together has a better rate of return starting from pre-design, and it just eventually it falls off once you get to construction and bid documents. You're not really looking to change any major features of the building, as far as orientation, lighting strategy, HVAC equipment, all that's been sized and, it's been standardized to meet code and be approved. Then you're sending it out for bid. So you're just producing at that point, you're not deciding. And so this, the meet target is kind of where, the lab or anyone that does energy efficiency and simulation, we kind of put checks and balances to kind of cope with this phasing of data release. And so, we ask, is it meeting our targets? Is it meeting our goals? Do we think, are we in a good range right now that we can move forward? If the answer is yes, then we're going to move forward. If it says no, okay, we got to go back and, start from the drawing board again. So one of the reasons why, we have that, lack of information sharing, it's not just, based off the process, it's, the file types of the software we're using. So the two biggest ones is IFC, which is Industrial Foundation Classes. It's a, standard developed by the industry, full life cycle of the building, generally used by model-based applications. Typically, when it first didn't have any geometric information. I believe the later ones have a little bit, but that's generally, dealing with geographical scale and building scale. The most important features that we're getting out of that are specific building attributes, as well as weather and climate information associated with that. The other big one you're probably familiar with is the Green Building XML, so GBXML. This was designed with the intent of transferring less than building scale data. So thermal zones, mechanical equipments, material thicknesses, material specifications, etc. So in that sense, to get a little more detailed, so we can, do less work when we transfer from one program to another. Instead of just completely starting from scratch, we have a baseline, or at least a foundation that we can start building off of rather than having to build the foundation again. So a little bit about IFC file types. It divides entities into rooted and non-rooted entities. Rooted entities, which derive from the IFC root, have an identity, name, description, and revision control. They follow a specific format. So the two you're probably used to the first one, the IFC XML. You're probably a little more familiar with the second one, just the IFC, which is text-based file. If you're using EnergyPlus, it's a text-based command line interface. So GBXML was developed to facilitate the usage of building information stored in CAD-based buildings in order to create that interoperability between building design and engineering software tools. So kind of like bridge that gap, kind of be a bridge where the architect and engineer can meet halfway and kind of start to have that discussion. It allows different users in multiple domains to use and transfer the properties of 3D building models to analyze for analysis and simulation. It was first created in 1999, so that's why you're kind of seeing the description, CAD-based building, because BIM hadn't really fully taken off yet. But it was done by the California Engineering Commission, peer program, PG&E, and Green Building Studio. Green Building Studio is Autodesk. So definitely be talking about them later. So the last couple of years of GBXML, you can see the milestones here. Autodesk has funded GBXML to perform level 3 data validation. In 2018, they had a benchmark of over 45 software tools now supporting integration with that file format. And then in 2019, happy birthday to GBXML. They're officially 2 decades old. And then they also hit the milestone of 50 software tools now supporting integration with the file type. And something to note is Georgia Tech University, they're beginning phase 2 of the level 3 validation work. So here's kind of an overview of probably the most popular software programs from their vendor associated that use GBXML. And so the one we're kind of interested in today is Green Building Studio. It's a building energy analysis web service designed for integration with existing 3D CAD / BIM software tools. Files produced by GBS is DOE 2.2, EnergyPlus, eQuest, VML, and X3D. You don't really need to worry about that last one unless you're virtual technology and design. Other notable software, just kind of give you an idea of where they're at, if they're considered BIM, if they're a plugin, their cost, kind of what they do. I need to pull up my notes through the key to the AV. So on the project phase, A is indicating that the software is useful in the conceptual design, where there's sometimes there's only a mass that is designed. B indicates that it works well with zones and the whole building, so it goes from building to space and thermal level. And C indicates that the software can make very accurate calculations and is capable of calculating energy use indoor. So those are kind of these are kind of more the engines behind those software applications. So you can kind of think of it as a multi-layer kind of a user interface for the interface, so to speak. So what we're most interested in today is Insight. Insight is a cloud-based software tool that empowers architects and engineers to design more energy-efficient buildings with the option to perform advanced simulation and analysis through Revit. So that's kind of the ideal utopia BIM program, is where everything can be done in a single program. You can have different file types, different storage methods, different actual software plugins, but the ideal utopia is to have them all living under the same roof happily and cohesively. So Insight, effective March 2015, new license to Ecotech analysis software, no longer available for purchase. So this is kind of just a roadmap for Insight. It's not the first version Autodesk has attempted to make. If you depending on how old you are or how young, Ecotech, you might remember that. I wasn't too big of a fan of its interface. And then out of Ecotech, we kind of get Green Building Studio. That kind of morphed into just being an engine rather than an applicable software program. And so then we get Insight 360, and that Insight 360 evolved to Insight, which basically the difference between that is Insight is cloud-based, whereas Insight 360 was local. but it did have the option for cloud features. So the reason is the aim is to allow Autodesk to shift resources, maximizing development efforts on a BIM and cloud-based solutions for building performance analysis and visualization. So Insight is a feature of the Revit AEC collection subscription feature. Installed with Revit as energy optimization. So the default installation, for 2018, 19, or 2020, you're going to have this feature available. The only so you'll be able to generate energy models, set parameters, settings, etc. But Insight is a Revit plugin, so that's kind of the interface for the tools. And so that includes solar radiation, daylighting, heating and cooling. I will say though, heating and cooling is a bit of a mystery there a little bit. It is present in 2019 as an Insight plugin. I don't believe it was present for 2018. And in 2020, it's now fully on the cloud version of Insight, that interface. So just keep that in mind. The goal for Insight is it would like to take the typical energy model program that are often very complex for architects to use, i.e. very high learning curve, and utilize them in early stages of design, i.e. Pre-design, schematic design, design development, to perform building analysis, where generally the building analysis and performance is analyzed at the later stages. So they kind of want to avoid that. Another thing is the goal that Insight's trying to fill is that it believes the architectural profession lacks established methodologies and protocols that incorporate performative analysis into early stages of design. Design decisions that have a significant impact on building performance, as I said earlier, are made during pre-design, schematic design, design development. And so that involves massing, orientation, volume, shading, daylight strategies, etc. So that's what Insight is trying to address. It sees this as a problem in the industry. This is kind of how it defines it. And so we're going to talk about how it's going to address that. So right off the back, I should just want to say, the point from day one is not to quantify the amount of energy, but rather provide the opportunity to enable a conversation with the architect, engineer, and clients. And that's from Ian Malloy. He's the senior product manager at Autodesk. He's in charge of Insight. So I just want to get that out, that Insight is not meant to be a one-to-one for Open Studio and EnergyPlus. And we'll get into that a bit later. So the left bullet points kind of describe what Insight is trying to achieve. So it wants to give you direction, but with accuracy, so let you know you're heading. It wants to take you from concept to detail, so it wants you to be thinking about building performance and the impact your decisions are going to have throughout the entirety of the process. As I stated earlier, it wants to encourage a conversation between the architect, engineer, and when applicable, the client. And again, as I mentioned earlier, the one model, utopia for BIM, one model to rule them all would be really nice. And lastly, it wants you to do it on every project. So generally, on the right side is the typical process or workflow for building analysis and simulation. Is we need to know exactly where we are and what the heading will be at each step. And generally we're already at detailed design, so we have all that information. It's great. Sometimes we have to bring in a specialist or refer to a dedicated engineer to perform those analysis or investigations. Generally that takes longer because they're performing a separate model. So we're exporting, we're watering down, we're changing features, etc. And then typically, it's only for special projects only. So, the client has expressed a very significant interest in reducing the footprint of the building. There's incentive you're probably trying to go for, or, perhaps it's the, this building happens to be, trying to meet the AI 2030 challenge, things like that. Skip one there. So where are we going? I mentioned earlier in the introduction, Insight leads to PAM, which I'm calling Parametric Analysis and Modeling. Don't quote me on that. I don't think that's actually a term. I just kind of made it up because that's just, so you can break down into two versions, so parametric modeling and then parametric analysis. So parametric modeling is you're modifying physical geometric features of your building. So a great example would be the window to wall ratio. So you place your windows, 4x4 window, and you have 10 of them on your south facade. Well, you want to know what happens if, you go to a 2'6" window, or if you go to a 2'10", or if you go 6x6. What if it's single pane, and then you want to investigate if it's, if you add 2 panes and add some low-E coating on it, what happens? So rather than making a model for each instance that you're changing so you can see the progression and the impact of that change of that design decision, parametric modeling lets you have a base version and then apply variables to it that will manipulate the geometry on your behalf. And then parametric analysis comes into, we're going to run a simulation for all those instances. So you have a typical window, 4x4, 10 of them on the south facade. You're not going to input any variables to change the dimensions, the coating or the material properties or anything like that. Instead, you're just going to let it run the simulation. And then in addition, it's going to run the simulations for everything I mentioned earlier. If you have a 10-foot by 10-foot window, if you want to go 6 by 6, 2 by 6, triple pane, double pane, it's going to run all those for you and just give you the results. So they're very similar, but their approaches are different, and one is local-based and one is cloud-based. And together, they're very, very powerful. They give you a lot of options. So I'm going to briefly speak about the simulation methodology here at the lab. We actually gave another BSUG back in 2018. If you just want to search on YouTube for UIDL channel, BSUG 2018, April 26th. Myself and Dr. Woods presented on taking CAD-based drawings and models into EnergyPlus, Open Studio, and Radiance, and kind of the process we go through that. So if you want to have a detailed, in-depth look, I recommend going and watch that video. But so the lab's process is we're going to be exporting or importing model geometry into various programs. Our predominant modeling program is SketchUp. Then we're going to be translating file format and building data. So we're going to be examining the model depending on the program we get it in. What information is stored there? How easily is it to extract it from the software program through exporting, or should we just manually transfer it ourselves? Same thing goes with the model geometry. How much of it do we think we can get out, or would it be better to export DWG plans of the floor, elevations, sections, etc. And then we're going to simplify the model geometry, so kind of get rid of anything that's unnecessary or that might slow down the performance of the model. Then we're going to define or redefine the building data depending on how well we are able to extract that information. And then we're going to, do the inputs and parameters, or GIGO, garbage in, garbage out. So setting those, your occupancy schedules, your space types, defining the HVAC system, lighting equipment, LPD, etc. And then we're going to say, does it work? So we use Open Studio. We're pretty good about getting models to work, but occasionally, we do run into hiccups where, we have to sit down and brainstorm and figure out what went wrong, what's not working. And so from there, once we get a basic simulation run, then, we're adjusting the model to create a baseline as built, then as designed. So are there any differences from there? And depending on the level of work, we'll go a step further and say, how is it actually operating? We'll actually go in and set up equipment to record, is the HVAC cycling on and off more than it should. Is, someone leaving the lights on. We'll set up, occupancy sensors, current transformers, flow meters, etc. Which also would be great if you can check those out from the tool loan library. And so then, once we've done all that, depending on the work, then we propose what-if scenarios. Would it be feasible as well as economical to, upgrade your T8s or T12s to an LED lighting system? If not, if, the client says no or whatever, it's just, they don't like the cost or the technology occasionally, then it's like, can we convince them to, to occupancy sensors? And, what would that do to the lighting schedule and the reduction of the LVD and how much money they're saving? So that's kind of the labs approach. Now we're going to get started with Insight's approach. So the first thing you do, when you open up Revit, new project, architectural template, that thing, first thing you're going to do, go to Analyze, go to the Analyze tab, and then go to the world with the pin on it, and set the location. First thing you do, don't model anything, set the location of where your building's going to be. Well, I'll get into that in a little bit, but that's very important. That's where your weather data and climate data is going to be pulled from. And generally, I found when I forgot to do this several times, so I recommend that be the first thing you do. But the Analyze tab, this is what you're going to see. As I mentioned, the energy optimization is installed with Revit, and then Insight is a plugin. So to generate the energy model, you're going to hit this guy. This icon right here, the X is going to change. So this is if you have an energy model present and you want to generate a new one, you have to get rid of the current one that's stored, and then there'll be a little sun asterisk that'll be for creating one. To generate an energy simulation, it's this guy. To optimize your energy model, you're going to choose this guy. It's kind of like a bar graph showing the energy trending down. What that really means is you're going to launch Insight. It's going to take you to the web-based interface. And then 5 is the energy settings. This is where you're going to be spending most of your time after you've built your geometry. So location. So when you open up this, the world map, this is the menu you're going to get. It's going to have three tabs: location, weather, and site. These green squares aren't here. I did this to protect the identity of the building, but it is. I can tell you it's in Mountain Home. So you're gonna, and you can do the search feature, kind of type in your address and search where it is. I found a more accurate, a quicker way, in my opinion, is go on Google Maps, type in your address, close it out, or close off that search location, and then click on the on the spot of the building, and it'll give you your latitude and longitude. Copy, paste that into here, and it'll give you exact positioning for the site. And so once you enter in that data, then you're going to get the option to select a weather station, and it's going to show you, where they all are. I selected this one. It's a little orange, 5.6 miles away. So the next tab, you're going to get your weather. It's going to ask you, this is a check by default, to use HVAC design data from the weather station. Say yes. It's going to give you a full spread of, dry, wet, bulb, mean daily range for temperatures. Excuse me. And then site. I believe this is more related to solar and daylighting, and it kind of comes into play if you're having multiple buildings on the same project site. So you're doing an apartment complex, and there's 4 different housing types or buildings, with the housing types in front of them, and it's on that single lot, so it's a complex. And so that's where this can kind of get into play. So if people are building each complex or each building within the complex in a separate file, but then you have a master file where they're all kind of placed in. This is kind of where that would come into play. Other than that, you really, I don't think you'll be using this. So you can just leave it as is. Next is going to be the energy settings. So that's this guy. It's the multiple graphs with the calculator bit. And so this is the menu you're going to get up. So one thing to note on the mode, the first line, you're always going to use conceptual masses and building elements. This was not explained to me, but in all the classes, tutorials, reviews, FAQ documents published by Autodesk, whether using conceptual masses or building elements, they now recommend that you use this one. There are two more options, one for conceptual masses only and one for building elements only. They recommend you do this mode. Their claim is that it's more accurate and precise than the other two. Ground plane, set the ground plane of your model. On this particular model, I labeled the actual level in Revit ground plane, so when you get confused. Project phase, you're going to set the phase you constructed your model in. If it's renovation, current, or new construction, you're going to specify that. And then we're going to get into depth about these next four. These settings are how Revit takes your architectural element model and generates an energy model from it. Oh, I guess I have a slide for that. So analytical space resolution. So this is creating the volume in that a space would occupy. So the default value is set at 18 inches. The minimum value accepted is 6 inches, and the maximum value allowed is 10 feet. And so what this does is Insight is built on the premise that you are a bad modeler, that you are not going to connect your walls. You might forget to, connect your wall to your roof plane, so it's connected to your roof, certain enclosures, etc. Things, that can tend to happen by accident. If you're so far along in a project or there's just a lot of detail going on, that could happen. So it assumes you've made mistakes. Okay, so that's why there's kind of an equation, if you will. So in this example, if we leave it the default value, if X is less than 18 inches, then the gap will be ignored and an analytical space will be created. So what it's saying is this area here, oh wow, there's someone late. This area here, say we didn't connect the walls. What it's going to do is it's going to draw a line here to finish making that space. So rather than ignoring it and saying just not making a space, it's going to operate on the assumption that you meant to connect that wall, and it's going to close that off for you and still create that space. The variable, so the min max for the mid range. So if X is less than, if X is greater than 18 inches but less than 36 inches, the gap may or may not be ignored. So this stems from the default value. It's just a basic 2-point multiplier. So if you had your the minimum value of 6 inches, then it would be if X is greater than 6 inches but less than 12 inches, it may or may not be created. Okay. And then the maximum is again the 2-point multiplier. So if X is greater than 36 inches, then the gap will be ignored and the analytical space will not be created. So that's kind of assuming that you're having an outdoor patio space or something that extends out, and so it's trying to just interpret that. So that's the space for creating volume. Now they have, that's supposed to say surface. I'm sorry, analytical surface resolution. So this is creating the enclosure of your energy model, your walls, roof, floor, etc. The default value is 12 inches. Minimum value allowed is 3 inches. Maximum value is 10 feet. So it works off the same principle as the space resolution, but this is surface. So if X is less than 12 inches, then the analytical surface for the section wall will not be created. So that's something different about it. So right here, so say this is 8 inches, this gap right here, then it's not going to draw this surface right here. Okay. And then if it's greater than 12 inches but less than 24 inches, it may or may not be created. And then if it's greater than 24 inches, then the surface, the analytical surface, will be created for that portion of the wall. Does anyone have any questions on that? I know I was really confused when I first was looking at these settings. Oh, okay. So another thing that's big is the perimeter zone. So specify the distance to measure inward from the exterior wall. The default value is 15 feet. So it's going to take 15 feet in and say, this is the exterior, and then what's left is the core of the building. So what it does that is because it's assuming, the heating and cooling loads are different from the perimeter than they are for the core because of solar heat gain coefficient, HVAC, etc. However, so definitely use this, leave this on, fine tune it. If none of your rooms or spaces are greater, than 10 feet, then you probably want to set the zone anywhere from, 6 to 10 feet, kind of within a range. However, if you have created thermal zones or spaces within your model, then set it to 0 feet. That's how you turn it off. If you don't, it's going to not necessarily overlay, but kind of combine and mesh with what was currently defined as well. And then you have perimeter zone depth. So, subdividing the spaces even further should be enabled when the perimeter is set, when the perimeter zone is not set to 0 feet. So if you are using this feature, make sure you have this checked on. It's just a checkbox. Results in more accurate energy consumption estimates because it's kind of zoning, creating individual spaces within the zones. So it's typically, what I should mention is that this one and this one, these guys, the perimeter zone depth, you generally only want to use those when you're massing. They are applicable if you're using detailed architectural elements, walls, floors, ceilings, doors, etc. But you want to make sure if you are doing that, you haven't created any zones or spaces. So here's kind of what that looks like. So here's spaces and rooms defined with zone depth on. So I've defined the rooms and spaces. It's kind of getting a little wonky in a couple areas. Whereas if we look over here, I have the spaces and rooms defined with the zone depth off. So we're not getting any jagged, extra, cut up spaces. It's all singular, as it was intended. So now we're going to briefly go over rooms versus spaces. Rooms are primarily used for creating schedules and organizing the building information with context. Spaces kind of take on a new meaning with Insight. So in an energy model, spaces are discrete volumes, masses of air that experience heat loss or gain. You can think of spaces similar to rooms in a building. However, because there's often a direct correlation between rooms and spaces. But if you look at the diagrams at the bottom of the slide, so there's multiple ways you can draw, your spaces. So one is that you could, be doing a massing model. So whether, that's just, massing form, or if you just have your generic, walls built in, you could say, I'm just interested in looking at a whole building level, just getting an estimation. You can go further and going further to a level by level basis. And then you go even further to go to a room by room or zone basis. And so here's kind of what that looks like further. So in plan, so I could have, a space for each room, or I could say, I'm going to treat all these 3 rooms as one space and look at them together. Same thing goes with plinth of ceiling area, HVAC area. You can either include the volume to be all in one, or you can break it out. Rooms are primarily used for creating schedules and organizing the information with context. So here's kind of an idea what you're going to be looking at. Just where does it build? What's the offset limit? What's connected to? Occupancy, wall, floor, finish, etc. Just basic details. Spaces. If you're looking to do an audit or kind of a one-to-one from Open Studio EnergyPlus, Spaces is going to be your bread and butter. This is where you're going to find a lot of detailed information that you would normally define in Open Studio. So your electrical lighting, electrical loads, mechanical flow, and then further, you got your identity data. So it automatically links it to the room. So if you create your room schedule first, and then you go in and add spaces, it is associated with it, but you do have to rename the space so that when you do export the data, you can figure out. So otherwise, it's just going to be space, 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 rather than the actual name. Energy analysis is probably what you're most interested in. It's going to tell you the zone, the plenum, if that's there. Is this room or space occupiable? What's the condition type? And getting further detail on space type. So there are plenty of options for determining space type, and you can also go in and edit these space types. I would recommend, still following the Open Studio golden rule of copy first and then edit. So you preserve the base version of the space type, and it's going to let you define quite a bit of information that you want, that you would typically be able to define in Open Studio. And then as well as construction type. So I think that's coming up. For the construction type, you have a very long list that you can choose from all the basic primary elements. Say roofs, exterior, walls, floor. I'll get in a bit later. You can also create construction types. So if you're working on a project and you want to save a particular type, you can save that so you can bring it into a later project as kind of a jumping off point. And so that's kind of what it looks like. It's just going to give you a default one, and you have to go in and choose from the list all these options on what you would like it to run as a simulation. You're also going to be able to determine your people and your electrical loads. So if you want to do it on a building level, if you want to do it by space type, that's possible. Advanced energy settings. So the first section in green, that's what you're going to be using if you're doing massing. The second section in gold is generic building definitions. So that's kind of the building level kind of detail that you would input in Open Studio. And then the purple, you need to, so if you're going to do that detailed options that I just walked you through, you need to make sure it's set to spaces, not rooms. Because rooms is just going to use the data defined by rooms. You select spaces, then it's going to choose to use the data provided in spaces. Then, so the bottom half, you can kind of think of it, the materials and thermal properties. You can kind of think of it, conceptual types is the pre-design phase. Schematic types is schematic design phase. Detail elements is the design development phase. And so room/space data with spaces can be best defined to be related to kind of like a baseline audit analysis, where you're trying to get, how is the building actually performing. So here's the options you're going to get in the conceptual types. So, it's very broad reaching. There are quite a bit, I believe it's 4 to 5 options per paint, per line. It's cold climate, mild climate, hot climate, no insulation. Schematic types. So again, this is kind of a step above the space level detail that we walked through. So that's what this is what it's going to use for your roof, exterior walls, interior walls. If it's generic type, or if it's a massing, it's going to apply these to it. It's all right if you have skylights, and if nothing's defined as a skylight, it's just going to ignore that setting. So it will only affect what you defined in your model. So the other option is detailed elements. I'm going to give you a big warning here. You should probably never check this option. The reason why is because this is what it's going to use. So say you've specified an exterior wall that's brick on metal stud. This is what Revit or Insight is going to use for processing, thermal, bridging, loads, etc. And it may not always do that accurately, and you are very limited on the options that you can choose from, and creating custom material definitions can be really cumbersome. But if you do want to do that, what you do is, after you go in this, you go edit type to the wall, make sure you copied it first. Then you're going to go in, select, actually once you're editing type, you're just going to click on a little icon. It's going to appear here once you hover over it. And then this menu is going to come up. It's going to highlight, what you're editing. It's going to give you the appearance, physical, and thermal properties. This right here is the thermal properties. If you would like to load in more libraries or additional materials, you can do that through here. So Edwin asks, oops, I went too far. Let me go ahead and, so now we're going to get into a little bit of modeling, walk you through it. So he asked, steel, wood studs at a given spacing, does this mean you need to create materials for each? No, I would not recommend doing that. If you want to, that's an option, a road you can take. However, what I recommend is going in here and the schematic design types. Okay, I don't know. Can you see that? I'm getting a thing that says, that's yelling at me that I'm sharing this window. I don't know why. But you open up that, and then you go to your interior, exterior walls. And you're going to see, there's options for wood frame, concrete, CMU, metal frame. So there are plenty of options available for you to choose from without having to go into the wall assembly and create each layer. That's really weird. I don't know why it's doing that. I'm sorry. What I'm trying to show you, I guess, if I can bring my PowerPoint back up, is this option, the schematic design. Yeah, I really don't know why that's happening. I'm sorry. Oh, it says my screen sharing is paused now. Okay, let's stop that and restart it. Maybe that will do it. Are you seeing the dialog box now? Okay, there we go. Apparently I had to restart it. I'm sorry. So yes, this is what I was talking about. So you see how I have a wood frame construction selected here with the R value specified. Tells you the U value as well. But you have CMU, wood frame, concrete, metal, CMU wall, heavyweight concrete. Like there are plenty of options to choose from. So you should not. I would again highly recommend not doing creating custom materials from your wall types and etc. So very quick, I would like to show you, but we are running short on time. So I am going to kind of skip ahead. Oh, lock me out. Come on. I have some simulations I've already run here for you. I'll walk you through those very quickly. But First, I just want to say, so when I was talking about parametric modeling, what I was referring to, on the analysis part, is this. So they're still using Green Building Studio, the engine, to run all of these. And so when I clicked on it, I believe it was V4. And so this is what it does. It runs all these simulations, every single one of them, so that it can give you, so this is what your model looks like, but what it's going to give you are these widgets, and the widgets, I call them widgets. I don't know if they're actually specifically called that. They might be called panels or panes or something. But the reason why it does that is it wants to give you a range of your options. In order to do that, it has to have run the simulation, you know, where you have the dial turned up to 100 and have it turned down to 0. And so what you can do is, if you click on it, it's going to give you these little options. It's going to tell you, you know, the watt. This one has to do with lighting efficiency, so it has to do with watts per square foot. So you can slide that over, and you see how it changes your EUI. I have it set to EUI right now. I'll go on a little bit on how to do that. And then it also gives you the triangle, and so this is what you've set in your BIM model, i.e. Revit, those energy settings we were just talking about. And so, you know, you can give it a range, or if you want to be, you know, no, I've defined, I know what my lights are, my LPD, that's what it's going to be. We're not going to change it. So then you can set it. That's how you set the option. Otherwise, you're operating in a range. And so it's giving you a range. Now, real quick, one thing to know about the widgets. If you come over here, this is going to give you scenario options. So you can set scenarios up like, you know, I've done a really basic one, pre-widgets, widgets moved. But you come here and hit the gears tab. We're going to set imperial or metric. Annual cost, or EUI, is how you change that. And this one's pretty important. If this is a new project and you're trying to get ideas on what strategies are going to be most impactful, you're going to want to have this as yes. If you're kind of doing an audit of the building, a one-to-one comparison, so to speak, you're going to want to have no. And, you know, so as you do it, it's going to update it. Utility rates, I'm a little less sure on. They do give you the option. So you just unclick that and you can input it in. However, it doesn't, I haven't seen or read anywhere that it's accounting for summer and winter changes to pricing. Other notable thing is if you, come on, there we go. You click these 3 dots. This is how you're going to export, whether you want that as a table data or as the actual file. So if you're, again, looking to do the one-to-one, it's going to export as a zip, and you're going to select, actually, sorry, I should show you, nope, not that one, sorry. I'm sorry, I take it back. Okay, let's try that one. There we go. So you hit export. It's going to give you an option for what files you want. Typically, you're doing a one-to-one comparison for Open Studio and EnergyPlus. You're going to be interested in these 3. You can also export, you know, your widgets, the costs, etc. And so what that's going to do is it's going to give you a zip compressed, and you know you're going to get the file types, and you can work right off of that. You know, and start editing and comparing to your model. So that's how you interact with that. So these scenarios, so let's go in here. So scenarios are right here. You click on this ribbon, it'll pop up. You create one by clicking this button to add a scenario. And so basically I have the option for, turn that guy back around, where it gives you, where it's going to organize the widgets from most impactful to least impactful. So like I didn't define anything in the building as far as lighting density goes, but the building is using T8s four bulb fluorescent, so it is pretty impactful. So I set something similar to that, and it gives me that. So it gives me that first, saying, hey, you're using quite a bit of energy, kilowatt hours. So let's talk about that. And again, that's the ranges I was demonstrating. So it's going to give you a history right here. This guy's a little confusing because it will record every single move you do. So it's not necessarily a good way of keeping track so far, in my opinion. Operating schedule. So the building is being converted into a DMV / police facility. The police are currently occupying it, but it was built in 1980 and was used as a forestry service building. So not really applicable. So the operating schedule I set was 24/7 because that's typically what's being operated now, which is the portion of the police department in there. And then you can change that as you're in, saying, I know we're definitely going to be 5, but let's say they just wanted to explore. So that's kind of what Insight is meant to be. It's a conversation like, hey, what if we did change the operating schedule? What would the impact of that be? Okay, and so maybe, hey, it's police officers. We can't exactly ask them to change their schedule. It's not really kind of a set job, so to speak, when it comes to time. So you could say, use this as an excuse for inputting occupancy sensors. And speaking of that, I believe, I thought it was, there it is. So we do have daylighting occupancy controls. So right now it's like none, but then let's say, what if we were to do just occupancy? And we go back up to here, and we give it that full range again. So you can just compare and contrast and see what that would happen. And it does it, for HVAC. It gives you options for all the steps, where you can go. And so you can do this for, a complex model that has, architectural elements defined. But typically what I would recommend using it for is kind of a jumping off point. There it is. That's the massing. Whether you're going to do massing. So the EUI range is, in my opinion, within tolerance and is an acceptable margin of error because it is a jumping off point. And so on this one, I purposely, set the lighting lower and purposely, set the roof construction to be uninsulated. So it would pop up first, just kind of testing, if you could, kind of influence how the widgets are organized, which you can. So it's, we're kind of out of time, a little bit over. I apologize. I will say I am doing a follow-up to this because there is quite a bit of information associated with Insight and Revit, all the options, the menus, additional features and add-ons. So a new thing we're doing for BSUG is we are publishing kind of like a blog on our website, idlpoesie.com. And so I will be doing a follow-up, kind of a how-to FAQ post about this lecture and kind of, expand in more, as well as, what resources I think are very good to have on hand, bookmarked for when you are working in Insight. So thank you for coming. If you have any questions, I'll take those now. Anything, maybe you're struggling with in Revit or Insight that you want me to go over real quick, I'll be happy to do that. One thing I should probably do, please fill out the poll. I forgot, Zoom changed the features. Oh, okay. Weather data. So let's get that guy out of the way. So weather data is going to be from the site, or say you go to the Analyze tab, you go over to Energy Optimization, you're going to click on the globe with the drop pin. You're going to open it up, and it is going to give you, or just type in Boise, Idaho. Oh, yep. So there we are, and then it's going to give me, let's see if I can make it a little bit bigger. Yeah, so then it's going to give you all the weather stations available that you can choose from, and the one that's orange is the one that's highlighted. And so if you're interested in looking at that, this is the information it's going to give you. It is your typical TMY file format that it is actually using in the background when in Green Building Studio the engine is running. And I guess for those of you still here, I guess one slide I don't think I got to. With massing, it's important that when you create a mass, you then add a floor. If you don't create a floor for the mass, then it will be treated as a shade object. And if you wanted to kind of get really detailed about your wall assemblies, and, you know, if you're going to do massing and spaces and stuff, you would want to create a mass with these detailed tools. But there's no other questions.